talking about a topic that I'm pretty excited about. It's a very important one. So why shall we learn about line width charts? Two reasons. One, that sometimes we are ourselves presented with misleading charts, either on purpose or with best intentions. Yeah, the media sometimes can be somewhat manipulative. And then also ourselves, we sometimes create charts that are not completely, not best in communicating information. So we should avoid that. Let me begin with a quote. Clutter and confusion are failures of design, not attributes of information. Today, I'm going to be sharing with you 5 pitfalls on the road to creating truthful and informative charts. I'm not going to reveal all of them in the beginning, but one by one. And that's because I like to make this session interactive. I'd like to ask questions to you. What's wrong with one chart or another chart? And I'd like you to write some comments in the chat. This way, we will all learn in the best way. Okay? And how information is organized today is we will go from things that are easier and more intuitive to something that's not so obvious. All right, are you ready for the first one? What's wrong with this chart? It's an easy question. I promise I will start with something easy. So feel free to send some comments in the chat. Oh, everything. Y-axis not starting from 0. Here we go. Yeah, Y-axis is truncated. Yeah, that's the biggest problem here. And why is it problematic? That's because a subtle trend in the data can be overly exaggerated. Yeah, magnified. In reality, the difference between these numbers is subtle. Okay, so shall we never truncate y-axis? Is that the rule? Let's take a look at another example. Here is another chart. Y-axis starts with 0 here. Yeah, so we are showing global temperatures by year. Okay, in Fahrenheit, y-axis starts with 0. However, there is something wrong with this chart, yeah? For some reason, it's not very helpful and actually not very truthful. It seems that the trend is flat. So can someone make a guess of why this chart is not perfect? The analysts did a good job. Yeah, they did not truncate the axis. They started with 0. So actually here, 0 doesn't have any relevance for us. Yeah, think about this data. If global temperatures were to increase by 10% point, by 10 degrees or decrease by 10 degrees, we would all probably be in very big trouble. Yeah, we really don't need to visualize whether they have ever been 55 degrees lower or 55 degrees higher. Yeah, the scale here, the range here on the y-axis is irrelevant for us. Instead, it would be much more meaningful to show the range where we actually care about, yeah? And all of a sudden we see a pattern. So actually sometimes truncating y-axis can be okay. So the first pitfall on our way was axis ranges. Truncate or not to truncate? That's the big question. Okay, let's move on. Next one. What's wrong with this chart? It's an easy question. 3D charts is a no. Correct. So what's the problem here? Yeah, is that, well, probably these three segments are the same size actually, but because of this third dimension, because it's a 3D chart, it appears larger than others. Information is distorted. Not a good idea. Okay. And well, probably many of you know that pie charts in general have a pretty bad reputation. Let's look a little more into this. So 3D pie charts distort information. Okay, but how about regular pie charts? Shall we never ever use them? So here I have one. Is it a good one? Well, no, maybe that's a not very good visualization. It's pretty hard to say which segments are larger and which are smaller. Yeah, because there are so many of them and the sizes are so comparable here. Okay, but how about something that we see on the right? Here we have only 3 of them and the sizes are so different. Is this all right? Well, actually, yeah, I would say this is totally all right. Yeah, so pie charts are often demonized, but I would say that actually sometimes they can do a pretty good job. Okay, next one. What's wrong with this chart? Too busy, yeah. Colors are hard to interpret, yeah. But something in terms of being misleading. Confusing is bad, but yeah, if you think about the misleading part of it, that's even worse. Double encoding, okay, yeah, that makes the clutter worse. Misleading with the fans. Proportion not correctly sized. Yeah, I think we are getting to the essence of it. So in essence, this chart is a bar chart. Yeah, at least that seemed to be the intention of the analyst who wrote it. They're using height of this of these shapes in order to show some variable installed capacity in megawatts. Yeah, the height is what's encoding the variable. But since it's a shape, when you increase the height, you also increase the width. Yeah, they increase at the same time. And then if you had 2 shapes, one was twice taller than another one, same would happen with width. And as a result, the area would be 4 times larger than the other one. So the magnitude of difference is exaggerated. Yeah, the scale is not correct. So here we encoded the same metric as height and as the width of the shapes. And as a result, the differences were exaggerated. Yes, and there are also some other problems, like labels are difficult to read, colors are confusing. Completely agree with that. It's busy, yeah, maybe not very successful chart in general. Okay. Some maps. Maps are usually really good visualization because they are engaging. Yeah, audience is usually very open to exploring maps. Okay, but are they always an effective way to visualize the data? So here I have a map of Europe colored by population. No tricks here, I promise. Can you tell me whether how population of Sweden is different from population of Estonia? Is it roughly the same? Maybe twice different, 3 times different? It's hard to tell. Yeah. Actually, the difference is 8 times, and Sweden is larger. Sweden has 10 million, Estonia has 1.3 million. There is no way to tell. Yeah, it all looks the same. So let's compare this to a simple bar chart. Here, probably we would be able to identify these differences much more accurately. Yeah. Okay, so does it mean that we should never ever use maps? No, absolutely no. But if our goal is to accurately compare some values between geographic regions, maybe we should give our audiences some cues to help them do this. Yeah, our brains are not very effective at decoding color intensity. Comparing 2 slightly different shades of gray is really hard. So maybe we can help our audience by providing labels or providing tooltips. Okay, so the second pitfall on our way was choosing right chart type and right variable encoding. Okay, let's move on. What's wrong with this graph? And probably once again, you will say many things, and you will be right. I would encourage you to look at the legend. So we are showing here a chain of restaurants in France, and we are encoding revenue as size and as color of the dots. So it seems like everything below 206 million is orange and everything above is blue. And the chart seems to suggest that all orange spots are underperforming and blue ones, 2 blue ones are performing well. However, is the middle of the interval really the best reference point here? Does this number have any meaning? Maybe actually something above 20 million could be called as overperforming. Yeah, like how is this even relevant? So the problem here is that I chose wrong palette for the colors. I chose a divergent color palette. Instead, it would be much more relevant to use a sequential one. So what do I mean here? Sequential palette is when colors go from low to high, and revenue would be perfect here. Divergent palette is where we have some neutral midpoint, some 0. For example, temperatures in Celsius, or profit, yeah, it has a 0. That would be a good use for divergent palette. And then we also have categorical palette, where we don't have any ordering for the colors, so they should not have any meaning. So the third pitfall on our way is the colors. All right, some more exciting stuff. Here I have 2 maps, and I can tell you right away they are related. Any guesses what's the difference? Why do they look so different? And this is a tricky question. Okay, for the interest of time, I'm going to reveal the answer. Map on the left is showing % of high school diploma graduates by county in the United States. The map on the right is showing percent of high school diploma graduates by county in the United States. The data is exactly the same. The level of aggregation is exactly the same. The only thing that's different is the buckets. Doesn't it completely change the story? The most truthful way to present this information would be without bucketing. Just present the continuous variable as it is. Bucketing can really manipulate the data. And sometimes some media outlets can actually take advantage of that to tell a story that they want to tell. Another example of bucketing, simpler one, is with histograms. Here I have 3 histograms based on exactly the same data. And if you had one on the left, maybe you would make a conclusion that your data is normally distributed. If you just decrease the bin sizes slightly, you would see that no, actually, we have something funky going on there. It's a bimodal distribution. We have 2 peaks. And then if the bin size was too narrow, we would see so much noise that we would maybe have trouble seeing the pattern. Yeah, so bin size really matters. Bucket size really matters. Most truthful way probably would be to try a few different bin sizes. And then if the story that you are seeing is different, then think very carefully which one is the truthful one that I need to tell. All right. So the 4th pitfall was bucketing. And then the final one. Here I have a map where I'm showing number of blue collar and farm workers for different counties in the United States. And this is default Tableau data layer. I have not done it myself. I have not manipulated anything myself. What does this map tell us? Any findings, like if we wanted to analyze where blue collar and farm workers are located in the US, what conclusions would we draw? Well, it seems like these farm and factory workers really love living on the coasts. Yeah, a lot of them are in the West Coast, a lot of them are in Florida, a lot of them are East Coast. Chicago area seems to be very hot as well. Wait a second. That's odd, no? Hey, why don't we just look at the population, just population of the US, just for comparison? Isn't it completely the same? It looks extremely similar. So what's going on is that when you plot something by count, this data is extremely correlated with just population data by county. We cannot even see the differences. Instead of doing this, it would probably be more meaningful to calculate rates. What's the percent of blue collar and farm workers? And then we can plot those rates. And all of a sudden, the pattern is completely different. Yeah, that's what we're seeing here on the right. So the 5th pitfall that we had on our way was the choice of the metric. And this is the one that's maybe the most important one and also hard to identify if it was manipulated. Yeah, sometimes you can select a metric on purpose that would tell a story that you want to tell, and the audience would not know. So we have to be careful there. All right, I promised you to show 5 pitfalls, and here they are. And some of you might get discouraged. Hey, there are so many traps on our way, so many ways to get our data visualization wrong. It's a hard job. Well, actually, let me finish on a positive note. I have some good news for you. You probably all have heard this quote. There are three kinds of lies: lies, damn lies, and statistics. Honestly, I had a trouble understanding what they mean here. Statistics is great. Yeah. Let's take a look at an example. So here I have some summary statistics. We have X variable and we have Y variable. And there is strong correlation between them, 0.8. Someone has drawn linear regression line and R squared is strong, yeah? So we could jump to quick conclusion that these two variables have strong linear association between them. All right. Well, actually, it's not one data set, but it's 4 data sets that have exactly the same summary statistics. And as you can see here on the right, these data sets are completely different. This is called Anscombe's quarter. Only first of them has linear relationship between X and Y. Dataset 4 is completely driven by outlier, yeah, otherwise there would be no correlation at all. And the summary statistics was hiding this, yeah. Yet when we did visual exploration of the data, we were able to reveal these insights that were hidden by the summary statistics. So how does this tie back to the topic of our today's talk? Yes, there are ways to lie with charts. Yes, charts can be misleading. Yet there are so many more ways to lie without charts than with charts. So as long as you are doing good visual exploration of your data, you are probably doing a great job. Thank you. If you have a couple of questions, I'm happy to answer them.